接下来呢，我们有请第10支队伍来自法国的 Pzartech， 请看 video。
Hello. Firstly, I wanted to thank Alibaba Cloud, its team, and also its partners, and also thank you, the jury, and everyone in the public, because you've been there since 9 o'clock this morning, and you already had a lot of startup. So I'm going to try to be as interesting as possible. So I'm Jeremy. Wow, this is a big presentation. I'm Jeremy. I'm the founder of Pzartech, which is a solution for spare part recognition for industrial maintenance. And before I tell you more about what we're doing, I would like to tell you about the problem that we're working on. This problem is downtime. Downtime is typically when you have a mechanical system that needs to be reviewed or that needs to be fixed. And when it happens, then you lose a lot of money, because for instance, in the aeronautic industry, that is the one we are currently focusing on, every time a plane is grounding, 1 hour lost is $10,000 that is going through the sink. And actually, part of this time is related to the difficulty that people have to actually identify the parts. If we're talking about plane maintenance, 7% of the time is wasted identifying the parts. If we're talking about corrective maintenance, on-site maintenance, then it's 4%. And this is why we've created Pzartech. Pzartech is basically a 3-step solution. First step, the technician picture the parts. Second step, this picture is being matched against the database of the manufacturer. And third step, through an integration, the technician can discuss with an expert, some kind of telemaintenance that we're working on with Cisco. He can order a replacement part with an integration with an ERP, or he can also get some more information about the part through an integration with a manual. It seems it's easy like that, but actually it requires a lot of work on the database. We're working on semi-synthetic data, work on AI, on neural networks, and also on computer vision. And also, for instance, on 3D data, we have deposed a patent. We have a patent pending on 3D data matching. And we've done that because the actual solutions are pretty inefficient and pretty cumbersome. If we're talking about what's going on in the aeronautic industry, what happens most of the time is that people go back to the catalog, or people actually have to read the part number, then write it down in order to be able to get more information about the part or order a replacement part. And so we thought that we can do better. And the market in general thinks that it can do better through visual recognition. For instance, PartPick, that is another company that was bought by Amazon, is doing 2D recognition. We are doing 2D and 3D recognition. And we're a small team. I'm in charge of the business. I have 10 years of experience in business development in the high tech. Adar is in charge of the product. She's basically an industrial designer, and Piotr is a specialist in AI. We are also being joined in our board of advisors by 2 searchers from the prestigious school, the French prestigious school, École des Ponts, that were part of the beginning of the project and that wanted to keep on contributing. And the way we want to make money out of this opportunity is the following. The manufacturer wants to sell more and more services instead of selling manufactured goods. And we believe we can enable them to provide a better service to their clients. For instance, the airlines that are doing the maintenance themselves or the maintenance services. So our client is the manufacturer, our user is the person doing the maintenance, such as the airline division that does the maintenance. Now, what we're doing right now is that we're starting a test with Israel Aerospace Industry. This is the biggest aerospace company in Israel. And we have also a lot of interest from companies such as Boeing, Air France Industry, and so on and so forth. And we're looking for funding in order to grow our team and to tackle those opportunities. We believe also that in the future, most of the industrial company will be using the cloud. And as such, we're very interested in being able to collaborate with Alibaba in order to tackle the Chinese market. So thank you very much for your attention. This is us in a nutshell, and I'd be more than happy to welcome your questions.
Thank you for your presentation. Now the question time.
I have a question. Thanks a lot for the presentation. What's the core competitive advantage of your localization technology over, compare yours to the others?
Thanks for your question. So we have two competitive advantages. One, in general, is that we do semi-synthetic data generation. What does it mean? It means that in order to run some neural network, you need a lot of data. And the problem is that you have very few data if we're talking about the product that we're talking about. Why? Because people don't put on Instagram spare part pictures. So first, we use CADs. And CADs is not a lot of data, but we augment this data through our technology. Or when we use picture, we do the same. We augment this data through our technology for the neural network to be able to train on it. Then on the 3D, we also have developed a technology that enables us to match 3D picture that are done with very simple camera that are the ones that arrive on the next generations of phones and tablets, such as the Intel SR300, with the data extracted from the CAD file. So technologically, this is our two advantage.
Any other questions? 还有其他问题吗？
Hello, Jenny. From my understanding, what you are doing is that you use computer vision to capture the images of the parts and then do the deep learning and the recognitions and then identify what is the part number or what part it is. Then tell the end customer, okay, this is the part. Is this all what you do? It seems it's a little bit simple. Well, actually, I'm not very familiar with the airline business, but is it a very critical issue for the end user to just to recognize what part it is? It feels like if I'm an aircraft engineer, worked for a few years, it's not so difficult to recognize just a few hundred, maybe, parts. Do we really need such a high tech just to recognize what it is?
So if we're talking about an airplane engine, you have 40,000 parts, okay? And out of those 40,000, you have something like more than 2,000 different parts. It means that you can know, if we're talking, for instance, about a regular engine, what is a piston. But it doesn't mean that you know that the piston is the piston XYZ 300. And most of the people that works on those planes don't know that every number that is entered. Even if they know what is the number, the problem is you don't know the number for the sake of the number because you have to order the replacement part or you need to go back to the catalog in order to get some information. So even though you know the number, you still have to enter it. And if we're talking about 2,000 parts, 2,000 different parts or 40,000 parts, you understand the waste of time if you have to enter this part number or if you have to search for the part number that is engraved. Most of the time, part numbers that are engraved are very hard to read. So we didn't come to this technology and this product by ourselves, but we've been told that it's a real problem that people are facing. But you are right in the sense that it's a pretty specific problem, even though every mechanical complex system has it. And as a result, we also consider growing in the problem that we're trying to solve. For instance, if we manage to raise the right funding, we would like to work on augmented reality and other subjects. But we have limited means so far, so we rather focus them on a very specific issue, on a very specific industry, and wait to gain traction here to grow further than that. But yes, it is a problem.
Okay, it sounds like a very, very smart tool and a very useful tool. But what's the business model for you? I mean, who is paying for such kind of smart model, smart tools?
Okay, so basically there are two kinds of players that are paying. It can be the manufacturer because he can resell the service. Or it can be the person that is doing the maintenance itself. If we're talking about Israel Aerospace Industry, at least the division that we're working with, is not manufacturing parts. But they have to deal with a lot of parts because they are doing the maintenance. So what we've worked with them is the ability for them to generate data and then to do the recognition. So the business model is right now on premises, with yearly license that we're selling either to the manufacturer, either to the maintenance department. And what we want to do in the future is to have a SaaS model. But we need for that to have those manufacturer and those maintenance department going SaaS.
As you have mentioned about the future market, well, in addition to the aerospace or airline market, have you ever looked into any future markets which is possible to fit into such kind of technology?
Of course. We've been approached for the boats market, the engine of boats, energy market. All market where you have complex mechanical system can be relevant to us, and it's quite a lot. If you're talking about the market of the industrial maintenance in the United States, it's $40 billion a year and it's growing. We don't represent the whole part of this market, but yes, we represent a small chunk of it.
Very impressive. Thank you.
Thank you very much.
And thank you very much for all your answers. Thank you. Please be seated. It sounds like a very smart Wikipedia for airplane parts.